So this is the water booklet that is just for triple. You can see there, triple. First thing you're going to have is a nice knowledge organiser, which again is mostly printed nicer for you in your booklet. So you can have a look and have a go at that, or use it to revise. Then we've got our keywords, like in every booklet. And then again, we've got our kind of like core knowledge questions. So I'm just going to put them here, and you can pause if you want to, but I'm not going to go through these in, not detail, but not going to stop and explain each one. But like I said, you can pause it whenever you want. Remember, they get progressively harder, so these ones down here are a little bit harder than the ones at the top. Again, with the kind of review sheet, I'm just going to kind of talk through it, but you can pause like that on the screen and just have a look. Big things, desalination, distillation, they might ask for the difference of these. Again, some core knowledge here. Knowing how like ion exchange works, boiling soda crystals is a good way, especially if you're doing the higher paper, to pick up marks. So, first question, there is a lot of reading, okay? So a lot of reading that you need to make sure that you understand, okay? So it does give you the information that you most probably need. Hard water is caused by the presence of calcium and magnesium. These ions come from compounds that are dissolved in water, okay? Temporary hardness is removed by simply boiling. Permanent hard water, so you will have learnt about that in class. Look at the statements, which one describes. They all contain some sort of calcium or magnesium ion, because if you look, they all start with quite a lot of soap recording lava. Obviously things happen, but all of them do actually start with some sort of hard water. What is the purpose of testing the distilled water? That's to act as a control to see whether anything else is affecting your results. In carrying out the tests on the sample, which variable needs to be kept the same? So we are changing the volume of the soap solution. We are measuring the soap solution each time and then looking at the number of shakes. So the things that need to be kept the same are the volume of water and the number of shakes. Which one? B contains a mixture of temporary and hard. The reason is it goes down. It does go down, but it doesn't go down to 2, which would most probably be soft water. Goes down slightly though. So explanation, results improved after boiling, but still requires some soap to form a lava. In your opinion, do the advantages outweigh the disadvantages? No, hard water requires more energy to boil. There's often limestone and scum, which cost a lot to remove. Now, if you were a brewer or a baker, you'd most probably want to live in a hard water area. Nice kind of question here. You want to think about this because it is 5 marks, could even be a 6 marker. Looking at just the method, that's all they want to do. So you could have used that previous question to help you. So first thing I want to do, I've got A, B and C samples of water. I want to make sure they're all the same volume. So I've got a really good control variable I can use. Add 1 drop of the soap solution and shake. Really, I should have written like shake 5 times or something. But you want to make sure. Then with this one, if you get a lava, you can just stop. If you don't, then you need to repeat, adding 1 drop each time and shaking it. Then, to see whether you've got temporary or permanent water, you're going to boil each sample. Soft water roughly needs about 2 centimetres of soap solution to form a lava. Temporary, about 10 before and then 22 after. Permanent will stay the same after. The reason why energy is wasted in homes, it requires a lot of energy to boil the water because of all the, also the pipes get blocked a lot. So that might be another reason, can't get to the area to heat the water. Complete the question below. They did give you a little bit of an example here. So it says hydrogen carbonate breaks down into hydrogen carbonate to form insoluble carbonates is an inexpensive way to remove water, okay? Remove hard water. So you've got CO2 and a carbonate. Explain why permanent hard water cannot be softened by boiling. Sulfates cannot form metal carbonates. In addition to sodium carbonate or passing water through an ion exchange, can often be used to soften temporary or permanent water. So they're talking about the ways to soften water here. What different ways we can do. So add sodium carbonate. The sodium can be exchanged with calcium. So you've got like an exchange. Sodium does nothing to your water, so it can go in and then comes out. Passing through an ion exchange, the ion can be filled with sodium. Again, very similar. This is just a cheaper method. This is using what we would consider like soda crystals. Disadvantage with ion exchange: once all the sodium has left and gone into the water, you have to replace it. Describe the effects of living in a hard water area. Build-up of limescale causes pipes to block. Nice graph then for 3 marks, plotting the results. You can see here it's a curve. Be careful to try and get all of your your points in. And then to finish off, describe how solubility changes. So, and if your graph, and I'll just put it by here so I can refer back to it, kind of looks like that. So as the temperature increases, so does the solubility, how much you can dissolve. A saturated solution of potassium chlorate was dissolved from 80 to 20. Describe what happens. You will see a precipitate form as less potassium chlorate can dissolve in the water.